Hi, I'm Josh, Ezzy. A lot of you have probably never actually seen Ezzy.
I'm real, not a
So we're going to talk about more of the technical nuances of what we're doing with the Actionable Analytics data mart, with slowly changing tables, simulated snapshots, how those function. And you could take this information if you wanted to build some incredibly massive user database tables, you could potentially take a similar approach. Not sure how the performance would be, but it's an option for you. So, we're gonna talk about what's the problem and how are we solving it. Simple. Here's the problems. So, other than snapshots, we don't have a lot of true historical data, right? Within the warehouse, especially from PeopleSoft. I think Workday's maybe a different situation in some cases, but we have a lot of effective data records, for instance, which are a picture of history, but it's potentially an evolving picture because the people working with PeopleSoft from the operational side do have the ability to adjust them. They can future date, they can backdate, lots of different things. So you don't actually know that's exactly what it looked like as of that date. So snapshots, we have those. That's exactly what it looks like as of that date. But they take up a lot of space. It's a lot of overhead. And if you have records that aren't changing frequently, there's a lot of redundancy within the data. So not very efficient. So with that in mind, without snapshots, without that true history, how do you do accurate year-over-year reporting? For instance, if I want to do point-in-time enrollment based off enrollment logs and effective dates and all that stuff, it's off by maybe 5%. That can be really substantial. It can make you look like you're 5% higher than you are or 5% lower than you are. For actionable analytics, especially, we're doing predictive models. So as of this specific day last term, what did each student look like? And we're using that to create a model that predicts future student retention. But you have to have that accurate point in time to do that. So there's got to be a better way. Welcome. Slowly changing tables, things, simulated snapshots. So what are they? The asterisks there. Usually they're tables. We do have like one SCT that's actually a view currently. So what we're doing is we're capturing changes to a record, but only when there's a change. So it's similar to a snapshot, but not quite. It's going to add a new row with all the current values, just like you get with a snapshot. But we don't have that redundancy because if nothing changed, we're not going to recapture all that information. For this to be effective, it's important that the changes come slowly. Because if you have a change to every record every day, you've just created a snapshot with all the same overhead. And the way we're going to process this data downstream is actually going to be probably less efficient because of the additional logic that comes into play. So for this case, we've created maybe multiple SCTs at the same grain to capture different information, which is expected to change at different frequencies. Makes the storage more efficient. So simulated snapshots, the other half, these are intended to be more user-facing. We're going to take the SCT data and we're going to restructure it so it looks like a snapshot. It's going to have the same usability as a snapshot, but we're not going to have all that back-end bloat. All right.
And because Josh and I didn't do a good job coordinating our slides, this is going to repeat a lot of what he just went over. So we have the traditional snapshots he was talking about, which is basically a blank copy of the raw data into snapshot tables. And the student profile snapshots have been around for over 10 years. In those 10 years, we've accumulated over 3.46 billion rows across those 5 tables. And especially in Oracle, that became very much a query performance issue where we had to create a subset of tables to just capture current or whatever people were most frequently reporting on. And obviously increased storage concerns. So then when we were migrating to Redshift, we said there's got to be a better way. Bill and Josh came to the data warehouse team and said, we have a need for snapshots. We want to snapshot all these things. We're like, no, because we're having issues with the student profiles. So we know that that design doesn't work. So we had a meeting of the minds and came up with slowly changing table, which is actually just a copy of slowly changing dimensions from Ralph Kimball. So credit should go to him. So yeah, the idea is that you're only copying changes or when changes occur. And like Josh mentioned, we have the simulated snapshots that sit on top of these tables to make it easier for you guys to use. The added benefit that like Josh covered is that I know that there's certain days where the warehouse doesn't run. And so you don't have those snapshots in your traditional snapshot tables, which creates a reporting issue. So now you have to account for, okay, it was Christmas and whatever. With this new design, because it does affect row valid start and end dates, it simulates that snapshot, even if the data, the jobs didn't actually run. We've seen so far, who knows, maybe in 10 years I'll regret this design, but so far we've seen improved query performance. And the only real issue is that it does require a higher level of skill to implement and maintain, because it is, there's a lot more logic that goes into it.
I put a little asterisk on that note we're missing snapshot days, because you're still kind of missing that change. It's just now you don't know it either.
That's true, but you don't have to adjust your
Query will still work.
your query will still work. So a real quick overview of the process that creates these slowly changing tables. It starts with the input data sets. So you have your current data from your source tables. And this could be a view. It could be a single table, or it could just be SQL that you're running and comparing the output of that SQL to your slowly changing table, which is your second input. Your slowly changing table is always going to be filtered to the current, because you're only comparing the most current data to the current data from your source systems. Then you run those inputs through change detection logic, and we'll go into details of what that looks like and what it is in a little bit. But basically you're matching the two data sets on a given key or case. And then you compare each column. You account for nulls because when you do a comparison operators against nulls, you have to account for that. And then just a pro tip, you should probably make sure that your input data sets have the same naming convention so that you can kind of automate that logic with the use of metadata. And then so finally, you create a change indicator column, which will have a designation of whether that row is new, deleted, identical, or it's a change. And then based on that change identifier, you're going to process your changes into your slowly changing table. So when it's a new row, it gets added to the SCT. When it's deleted from the source system, the SCT gets updated to mark that row as deleted in source. And if it's a change, the row gets marked as no longer current, and a new row with the latest and greatest data gets added to the SCT. So now we're going to go through a real quick example of kind of what this looks like from a data perspective. So you have a source system with a key 1, 2, 3, 4 and a value AAA. Yeah, was that 3? Whatever. You'll want to add the row deleted in source is equal to no, because if it exists in the source system, it's no. And we'll get into details of how that works in a little bit. But you saw this data come through the system on October 20th. And you ran it through your change detect logic. It said, hey, I don't have that in my SCT table. So it goes and adds it. The row valid start date is the date which you processed that row, which is October 20th. The end date is the end of all time, or at least my lifetime. And row current flag is equal to yes, because that is the latest and greatest data that you have from the source system. Then on the 25th, you see that the value for that key changed to BBB. So this is what your SCT looks like. You run it through your system, it identifies a change. So what it does is it marks the row current flag equal to no now, because it is no longer current. It updates the row valid end date to the date that you processed it, which is October 25th. And it adds a new row, again, with the valid start date and end date being today's date and end of time, row current flag equal to yes.
So first row's end date time is actually like 1 second before, just to make sure there's no overlap.
Yep, thank you. We'll show that in the update, but so if you can see here, it's 10:25 at 6:14:22. And then the next one is, so it's always the start of the job minus a second so that there's no overlap between the rows. So on the 29th, the row disappeared from the source, which we see often. So now what will happen is that row, your current row is going to be marked as row deleted in source. And the end date is changed to, again, the start or the time that your job ran. Do note that the row current flag stays yes, because that is still the latest and greatest information you have. It's just been deleted in the source. And then on November 1st, the data comes back. And nothing's changed. It was just added back, and we do often see this. So it is a valid example. So what happens here is runs through your change detection logic. It says, hey, row deleted in source is no, but I have it as yes. Nothing else has changed, right? So that's the only way you can pick it up. That's why it's essential for you to have that row deleted in source equals no in the source input. So it detects that change. It updates that row, the existing row, to the row current flag equals no. You don't change the row valid end date this time, because you don't want to artificially put row valid end date of 11:01, because that was in fact deleted on the 29th. And then similar to before, oh, you can see it in here. I'm talking over it, but it's just adding a new row with the new valid start date and date and a new current flag. Whew. Change the tech logic. So this is kind of where all the magic happens. So we discussed you have the two inputs, right? Your source and your SCT current rows. You're going to join those on the business key using a full outer join because you want to capture everything from both inputs. New rows, this is going to sound like a bunch of words, but I promise they make sense. New rows, you can basically exist in the source system, in the source data, not the SCT, and the SQL equivalent is the SCT key column is null for that, because it didn't find a match against your SCT. Deleted rows exist in the SCT and not the source system. So the SQL equivalent to source key column is null because it's in the SCT, not the other one. Identical ones is really where a lot of SQL happens, but values match or both null. And so it's basically the column from the source system is equal to the column from the SCT, or source system column is null and SCT column is null. And that's what I meant earlier by account for nulls. And then once you've found those, the change rows is easy because you've accounted for everything. So change is just everything else. And this is what the SQL looks like. I'm sure the slides are going to be shared, but you can see the full outer join there. I'm filtering my SCT on the row current flag and joining on the term code in this case. Then that case statement is your change indicator logic where I go through and identify deletes, news, identicals, and changes. And if you named your input, both your inputs, your SCT and the source, to have the same column name, you can use the metadata to basically build out that third when condition, because it's basically going to go through potentially 40 different columns, and you really don't want to be writing that by hand. So you use your metadata table, metadata table to identify all the columns that you want to compare, and then just dynamically build out that SQL for you, which is what I did. So in this case, it's comparing the start date and the end date to make sure both of those.
Curious, at some point, if you've got like 300 columns you're comparing, would it be more efficient to unpivot the data to do a single value comparison for multiple rows rather than a multi-column comparison for a single row?
Potentially. We'll get there when you have 300.
We'll get there soon enough.
300 columns, yeah. This actually runs pretty quickly. But yeah, I think you know, we have the added benefit of being in Redshift now, which is processing data a lot faster. But yeah, that's interesting. So yeah, so this is the SQL logic. And it will look the same regardless of whatever inputs you have. If you decide not to stick to a naming convention that enforces your column names to match across your inputs, your when statement's going to be pretty hairy. Okay, so that was that's how you detect the changes. You will want to persist that output into a table. And then it's just a matter of updating your FCT. So we'll start with deletes because those are the easiest. You're basically just saying when my indicator said that this row had been deleted, you're going to update the row deleted in source flag equal to yes, and your row valid end date equal to the system date stamp minus a second. And yeah, then you're just joining on the keys, which in this case will always be the term code and the valid start date, because remember, this is capturing changes. So a term code will exist multiple times in your data sets. And then the last thing is you'll want to add this filter to make sure that the row deleted in source flag isn't already null. Because otherwise it's always going to be picking up that deletes and you don't want to keep processing it forever. So just process it at one time. Then changes is also pretty easy. Same deal. You're using your change detect output, filtering on the change indicator this time, which is a C or whatever you want it to be. Joining the data on your keys, and then just setting the current flag equal to no, because remember something came up, and so that current flag is no longer valid, and the row valid end date is equal to, this one's going to be hard to explain. It is equal to the date, the sys date minus a second, unless it's that deleted case, in which case you want to preserve what's already there. So that's what that else is for. And then the last part is you've taken care of your deletes, you've taken care of your changes. Now it's just a matter of inserting new rows in the changed rows with the latest and greatest data. So that's just an insert statement into your table where you're setting your row valid start date to the sys date. Row valid end date is again the end of time. You're processing all your attributes from your current input data sets, and then whatever that is, and then row current flag is yes, row deleted in source is no. The end. Speed run. It'll make sense once you go play with it if you want to.
Are they sending out survey links? That's actually been communicated. I guess there's gonna be a survey link going out, so.
Be kind.
Also, I put a couple links on here. Obviously, you'll have to have access to the deck to click on these, but there's some documentation that we put together on more user-facing rather than creator-facing. So how to use SCTs, SSNPs, some tricks and tips there. And you can also get to that from the Actionable Analytics Analytics portal page. So if you search for Actionable Analytics, in the Analytics portal, you go there. If you have done FERPA training and you have like, if you just say like, want to see the data mark stuff, you'll get approved. Also presentation tomorrow morning, it's going to be more data user facing rather than this, which is more data creator facing on what we've done so far in that space. Questions?
So are we still making this just it's actually just databases or
so everything we've done for actionable analytics that's end user intended is in Redshift. So if you go into Redshift and you search for SCT, SSNP, you're going to see all our stuff. It's mostly in the student analytics schema, which is kind of restricted, We do have some stuff out there in ASU students. We have a class dimension, we have a plan dimension, service indicators, student groups. And for, I, yeah,
Other thing, John is just college or we have a teacher. So I'm always curious, like, well, first of all, there's no threat of me going out to make this kind of this tomorrow. Not to worry about. But what is the cutoff? Where do we say, okay, this is something that we can build as for people? Where do you do that?
I mean, I have to be careful because I kind of want to answer this from my Ed Plus position, which is if ET is not doing it, then I'm gonna do it. That's the threshold, right? If they're not gonna do it for me, I'm gonna do it myself. So obviously we're working with your department now with the Enterprise Enriched Datasets project. I know we have made a lot of progress there. Elizabeth recently hired a new analyst who I just started working with on that. So we're starting to make some momentum. So we're going to be doing some of these in Redshift for admissions data. If you have something out there you think would benefit from this, if it's in the student data space, you can talk to Phil Arcuri over National Analytics or Elizabeth Riley and ET to get it on their radars, get it in the backlog, prioritized, resourced. If it's not student facing, the National Analytics isn't going to touch it, but Elizabeth Riley still can potentially take it on. Yeah.
And if you wanted to build it yourself and start capturing the data, you totally could. And if at one point it needs to transition over to the data warehouse to be more enterprise, we could bring that data over and then transition the process that you created over to our side.
I did build one of these in user databases for, I think, Canvas assignment submissions or something at some point, and it worked in Alteryx for about a week before it completely blew up, but you can do it. Once you get to a ton of data, you have to start thinking about indexing, adding primary keys and all that stuff, just to make sure it functions. But
yeah, and the areas I'm not efficient, but like spirit mathematics, as a little like that's not just a pure yeah, that's some scripts. No threat.
Yeah, in our, like, most of us don't have access to do anything that's in the anything, so we wanted to create something like this, it has to be.
I mean,
Laugh at, but then I.
technically you might have your own SQL server or something, but for the most part, you're working in BI, it's gonna be. Really quick.
So what do you do with changing data schema to source as our KCP data?
You have to admit, so like if a table changes schemas,
You follow this further.
yeah, so if a new column is inserted in your filter process, it's not gonna automatically go in there. So it would just continue comparing the columns that you know about when you first developed it. But once you become aware of that, you can add it. If the schema changes, your possible break-in, you'll get called and have to fix it.
So we have a curated development process. We're not, these changes aren't being captured from, select star from this table because it would just break, right? So we have an underlying query where we've specified every detail of it. And if we want to make a change, we go in there, we make the change, but we tell Ezzy because she has to actually implement it.
Yeah, and then something I didn't cover was backfilling these, because obviously you only start collecting history from the point you start writing the process. You could in theory backfill, but you're gonna have to account for the dates and it gets a little complicated.
If you have actual snapshot data on something, then you could backfill just by kind of deleting all those redundant rows and inserting them. But if you're dealing with effective dates and all that stuff, you have to make some assumptions. You have to be okay with things being maybe incomplete or not completely accurate. It is something we're we're constantly kicking that can down the road at the moment, because it's very scary. Gonna get this. I mean, the simulated snapshot it's essentially a snapshot, so you can join it on snapshot day and all that stuff.
So. The point about how the snapshots are used and. Not. Has anyone prepared, size or anything like that, with the, and tables, here's the. Going to get to the point where we're gonna convert it all to this.
Well,
And research.
I know, right? It is, at this time, it is unlikely we're gonna convert existing as a traditional SMPs into this design. We might do something where we do SCTs going forward, but for historical data, we could use those just because it is very labor intensive to try and convert it from a snapshot every single day to one that's reducing the size. It's possible, maybe if we hire more people.
You did do a comparison.
I did. I don't remember those numbers, and that was like a year ago. But
A general idea of what it was. So the SCT contained about 1% of the data of the snapshot. And the performance was actually as good or better. I want to say it was like a 5% increase or something, or decrease in query time essentially. So we got better performance and less storage.
yeah, and we also have a process that runs a kind of a sanity check. So while you're developing, you do want to make sure, and that's touched on this, that it is in fact a slowly changing table, because you're adding all this complexity and all this logic. And if the data is changing every single day, it doesn't make sense. So we have a process that will audit the number of rows we have, the number of new rows that were inserted, and make sure that it's within an acceptable range. There are times where we get a notification, and it's usually like, I think service indicator every end of the month. They do an adjustment of balances. And so I get a notification right now, the end of the month, and verify. But yeah, for service indicator, I think, I don't even know how many rows we have, but it's a very small percentage of new and changed rows that we're adding to the snapshot as opposed to the whole data set every single day.
Yes, it's a big one.
Yeah.
Day enrollment opens, that's another one.
But I mean, it's once in a while versus like every single day capturing the same stuff, so it's worth it.
Did it. I think we're technically out of time. Yes.
I think you got it technically.
Oh, we do? Okay.
Oh.
So we got 3 more minutes.
What's up?
Like, do you have any, like, good sources for like people who are learning the kind of better support? Like, I would do
that. You know what, honestly, it's for me, it's been a matter of like learning from other people. And when I started at ASU, was really when that began, because before that, it was like an IT team of 1, and I was in charge of all the SQL and database stuff, and I was like, well, it works. But it was not pretty. And then you know, we go through like a tech review process. So I think for me, a lot of it has been learning from what other people do. And I don't know, just playing with the data. I don't know what to tell you.
Post those queries in SQL support, take that feedback.
Look, there's some of the stuff that Josh does.
Yeah, well, Josh will answer, and then he's like, well, I'll never.
You'll notice she didn't ask me.
Oh, you.
No, but so Josh, I think the source SQL is available for some of these things, right?
Everything. So that data mart page that's linked, the second one, it has a link to that first document, but also it has links to basically all our documentation around the SSNPs and SCTs. You can see our entire development process, our specs, thoroughly, all our code. It's all there. There's summary sheets that have like tips and tricks and example queries for every object we've created. It's very comprehensive.
But if you look at specifically that SQL document, which Josh creates and maintains, he's got really good SQL in there. And then the other day he threw a recursive query at me that I'd never seen before, and I was like, what is this doing? Took me a while. So it's just, exposing yourself to different ways of writing SQL that'll give you a perspective on things.
So when you make it a problem for these different environments, you make. So you get like data SQL for these environments, then you for the other environment. You have to do like.
Yeah.
And that's why you want to use
And see.
ANSI.
I didn't even know what you were talking about. I'm gonna get it wrong.
We did an entire SQL support meeting on this.
Automatically, no, I'm just,
No.
I think it's fine, like, my try level is here, and then like if I do it, it's not like, you know, like, yeah. Of course, it's perfect.
If you are ever interested in it, I think a good place to start is trying to clean up data and make sense of it. Because we have some really weird data and we have to do like simple acrobatics to try and get it to make sense.
I think I was about to work on something like that with
She's gonna take the first pass at that person table that I've been putting off.
Mm.
that we didn't work on it yesterday.
Yeah, same thing happens when you don't show up.
All right.
Thanks, everyone.